Who are we and why does it matter? Dalan Animal Health, something you've never heard of, and you may read it and go, is that Dalan, or how do I say it? We say it Dalan. Where does the story come from, and why are we here, and what does it matter to you? So you see these three scientists here. We got Francie and Dahlia and Annette. They're the three co-founders of this technology and of Dalan Animal Health. In 2018, they decided to bring the research that they had to the people who need it the most, the beekeepers and the colonies that they take care of. And so they went to the University of Georgia, set up an innovation hub there. And from there, we've have a privately held biotech with over 15 employees now. We got registration in US last year, or earlier this year rather, and registration in Canada just a couple months ago in October. So we're moving into the market as quickly as we can, as the regulatory agencies would let us move. We are committed to providing transformative animal health solutions to support a sustainable future. You saw that in the cover slide, really. Healthy animals, healthy planet. And that's really the passion that we're bringing to the table as a team, not just the founders. And so we're really excited about what this can do to help colonies out, alleviate some of the pressures, and even add to our food supply chain. As we move to the next slide, we are going to talk and hear from, we're going to hear from Miss Amy Floyd. She has her master's from the University of Arizona. She master's in entomology and insect science. Before that, her bachelor's wildlife and management. Sorry about that. We're going to be listening to her. She has spent a lot of time in the field in over 7,000 hives with this vaccine and with honeybees. She has her own honey business rather in Tucson, Arizona. She was first came to know about Dalan in 2020 as she was working at the USDA ARS, excuse me. She was doing research there at UC Davis in conjunction with them. And after that work was completed, she came on full time with us. And we're so honored to have her not only on the team, but to have her speak to you tonight. There's no one that knows more about how this works in the field than her. And with that, we're going to turn this presentation over to her.
Okay, thanks, Everett. I'm excited to have all of you here. This is one of the biggest groups I've ever given a talk to, so I'm excited. So I'm going to go through kind of the agenda, what I'm going to talk about today, and then I'll dive right in. So I'm going to kind of touch on honeybee stressors and the thing. I also have to apologize for my dog. We are in a new place and new noises are making him a little anxious. I apologize. Okay, so I'm going to touch on honeybee stressors, and then we're going to walk through the honeybee immune system, which is sort of how we've decided to look at honeybee health, is starting with the bee. And then I'll walk through our immune priming technology, and then walk through the data, the efficacy data, and the trials we had to go through in order to get our conditional license. And then how to use the vaccine and how to get the vaccine. And then I'll sort of talk about our experience in the US so far. And then I'll hand the reins back over to Everett at the end. Okay, so if you're on this webinar, you probably are familiar with bees in some way and have heard about a lot of the different things that affect them and their health. And I've maybe experienced some hive losses yourself. Most beekeepers experience a 20 to 45% annual loss of hives due to a number of things. A lot of that loss happens over winter, but there are a bunch of other stressors that cause the weakening of hives that can lead to losses as well. Disease pressures, bacterial, fungal. There are a number of different diseases that affect bees. We have pests, hive beetles, mites, mice, wasps, kind of you name it, something will figure out how to bother your hive, bears. We have habitat loss is a big issue. Lack of forage during certain times of year, the climate changing and larger weather events happening every year are causing a lot of hive losses. And misuse of pesticides or poor timing of the use of pesticides always ends up leading to a few lost colonies as well. So one of the major stressors that doesn't have any really good solutions right now is American foulbrood. So this, although it's called American foulbrood, it is spread across the world at this point and can be found anywhere where there are colonies. So AFB is caused by a sporulating bacteria called Painobacillus larvae. This bacteria gets into larvae via contaminated food, and it's usually in a vegetative state until it gets into the larval gut, and that's where it's able to reproduce. But those spores in that vegetative state can exist in the environment for decades, on wood, in wax, in honey, in pretty much you name it. It can exist in the soil, on trees, and so that they hang out in this vegetative state, and once they get into pollen, that's mixed into royal jelly and then is fed to a larva, it gets that opportunity to start reproducing again. And these spores are still present in up to 50% of hives looked at in the US and Canada when you look at studies combined. So one specific example is this study that was done in Connecticut from 2009 to 2012, and they showed that up to 45% of hives still tested positive for spores. They weren't necessarily showing symptomatic larvae. So they weren't having larvae die, they weren't seeing the melty, blackened larvae or anything. But they were seeing, so these blue bars are that subclinical disease. So those spores are present, but they're not seeing signs in the larva. But these clinical outbreaks can be caused at random, but also when hives are stressed. And like we just talked about, there are a number of stressors for bees right now. So if those spores are just hanging out in a hive, and the hive gets weakened from something else, from mite pressure or lack of food, anything, that those spores can kind of take more advantage. The bees aren't as good as fighting off those things, not as good as cleaning the hive. So that can cause a subclinical to transfer to a clinical case. We also, robber bees or contaminated equipment can also be a way you might see a clinical outbreak in your hives. And a lot of these, not a lot, but these AFB strains are starting to present as antibiotic resistant. So antibiotics that were used in the past to suppress the AFB are no longer effective in certain areas. And that kind of thing is just going to grow. And as antibiotic use has gotten more restricted, we're starting to see more and more AFB outbreaks around North America. And so right now, antibiotics are kind of the only tool that beekeepers had to sort of limit the extent of AFB. But antibiotics are really bad for bees. They alter the gut microbiome of honeybees, which alters their health pretty significantly. Just like us, right? When your gut microbiome gets messed up, you don't feel great for a while. And it's also, where we're perpetuating this cycle of creating resistant strains to antibiotics. So they're getting less and less effective anyway. And then we have the contamination of honey with antibiotics that limits your ability to sell your honey. And then we're also, exposing humans to antibiotics and making certain antibiotics less useful for us as well. So they're just really not the greatest option. I know we've been limited in our options so far, but they're really not great. The other big one for AFB, if you've heard about AFB, is probably that you're required to burn those hives if you do have a clinical case. And no one likes doing that. It's costly, it's time consuming. You also have to quarantine other hives from that apiary, which is also costly and time consuming. So American foulbrood kind of has this big hole in treatment options. And a lot of the options that are out there in general for beekeepers to use on their hives are either dangerous for the bees, or you might lose your queen, or they're dangerous for the person applying them. They're heavy chemicals. You can't extract your honey while you're using them, or you can't take your hives to organic farms. So we kind of have some solutions as beekeepers for these stressors, but not nothing great, right? We kind of do the best we can with what we have. And so new solutions, we need things to be proven. We need to know that they work, not just some snake oil. We need less chemicals in our hives. We need to be safe for the bees and for us, and for anyone consuming our honey. There's a need for a change in the way we take care of bees. So Dalan wanted to look at to approach taking care of honeybees differently. Instead of treating a problem once we have it, how can we prevent these things from happening in the first place? And to do that, we needed to understand the honeybee immune system for some of these more pathogenic issues. So how does the honeybee immune system work? There was a lot of argument for a long time about honeybees not even having an immune system, but they do. And they have a lot of tools in the immunity tool belt at different levels. So we know honeybees are a superorganism, right? We have the individual level, and then we have the colony level. And at the individual level, they have gut symbionts. They clean themselves. They have antimicrobial peptides. They groom each other. We have lots of different options for them taking care of themselves. But then at a colony level, they use propolis, which is antibacterial, antifungal, to insulate their entire hive. They have hygienic behavior amongst themselves, and within the hive, they clean out dead larvae. They also try to get rid of dead bees. They have undertakers who are shooing out those sickly bees. They thermoregulate. They will create a fever in their hive if they feel something bad going on, to kind of heat kill it. They have task specialization and food sterilization to try to get rid of contaminants within their hive and try not to spread them. So bees at individual and colony level have ways to take care of themselves. They do have immune systems. But the queen really plays a much larger role in the immunity of a hive than we sort of originally thought. So the queen immune system is actually very well studied. A lot of work has been done on that, and we understand how her immune system works as an individual. And it works kind of how you would think it would work. She is infected by something. She eats contaminated food. Her body recognizes it in the hemocell. So her blood, it's recognized. Her fat bodies activate a response, which means genes are expressed that promote a defense to fight off this contaminant. This other really cool thing that queens have a lot of is vitellogenin, which is one of the oldest yolk proteins in all animals. Anything that lays an egg contains this protein, but queens happen to have it in really high abundance throughout her entire body. And so vitellogenin helps the queen pass on this immune response to her offspring. So this is called transgenerational immune priming. So when her body recognizes a contaminant, these recognition receptors are activated, and so these recognition receptors recognize the AFB bacteria as something bad, and they can attach to vitellogenin, and that vitellogenin moves into her ovaries and then into the egg yolk, since it's an egg yolk protein, which is then allowing the larva to be exposed to that recognition receptor before it hatches. So when it does hatch, it is primed to fight against that bacteria or that contaminant that the queen's recognition receptors saw. So that's why it's called transgenerational immune priming. It's moving from one generation to the next, and we're priming their immune system to fight off a infection. So how do we use this to our advantage with honeybees? This leads us to our first vaccine, our first product for American foulbrood. This is really a sustainable solution for fighting off a pathogen in honeybees. It is currently conditionally licensed by the USDA CVB in the US and the CFIA CCVB in Canada. And so the vaccine contains inactivated bacteria, so it poses no risk of an AFB outbreak. And this is used, again, as a prophylactic method. So we're using this to prevent an AFB outbreak from happening in the first place. And as I kind of alluded to, it is chemical-free, non-GMO. You can take your hives to organic orchards if you need to, if you wanted to. You can also extract your honey while you are using this product. The vaccine doesn't limit the things you can do with your hive in any way while you're using it. So I'm going to walk through how this works, and then we'll have a kind of a video to summarize it again for you, just to really hit it home. So first, the vaccine is mixed into queen candy. So that fondant-like candy that's used for sugar plugs, or if you've ever received queens in the mail, that fondant-like candy that's in the bottom of the box for the attendants to be feeding on, that kind of candy. So the vaccine, the Bacterin, is mixed into that. And then worker bees consume that vaccine that's in the candy. Then they digest it and transfer it to their hypopharyngeal glands and feed it via royal jelly to the queen. So that's kind of a long pathway, right, to get from the worker consuming it all the way into the eggs coming out of a queen. So to confirm this pathway, fluorescently marked bacteria was added into queen candy, and workers were exposed to it, and then we dissected out the parts of the workers that we needed the vaccine to be getting to. So the first place we need to make sure it's getting to is the midgut, and so these pink particles in this photo are those bacterial particles that this worker consumed, made it to her midgut. Good job. Our next stop is the fat body. So fat bodies are actually where the nutrients for the hypopharyngeal glands comes from. So we need to make sure it's getting to the fat body. And as you can see in this photo, again, those little pink dots are present, meaning those bacterial particles made it all the way there. And then hypopharyngeal glands are last, but definitely not least. This is how workers feed queens. So we really needed to make sure these particles were making it to these glands and into the royal jelly. And once again, you can see those pink particles. So we confirmed that pathway. So the workers, they're feeding it. It's working its way through their system over a week. And then those workers feed the royal jelly containing that vaccine to the queen. The queen digests the royal jelly. It stores in her fat bodies, because her fat bodies are actually what feed her ovaries. And then the vaccine is transferred to her ovaries and passed on to her developing eggs. So we also did a similar study. We used a green fluorescent marker for this one. But we needed to make sure everything was getting to her ovaries as well. So you can see those green particles in her ovaries. And then those developing larvae are resistant to infection as they hatch. So here's our little, make sure I can play it. Yeah. Here's kind of an animation of what I just walked through. It's a little bit more visual for you, a little repetitive, but I'll kind of walk through it as it goes as well, just to really hit home how this vaccine is working. So this is the worker. The worker consumes our little red vaccine particle, goes to her midgut, into her fat bodies, and then her hypopharyngeal glands. And then once it's in there, she feeds it to the queen. And when the queen consumes it, it again goes through her midgut and through her fat bodies into her ovaries. And then when she lays an egg, they are primed for when they hatch to fight off this pathogen. Oh, okay. So in order to get our conditional license, both in the US and in Canada, we had to prove some things: safety, efficacy, purity, and batch consistency. I'm gonna speak to safety and efficacy today. Batch, consistency, and purity are kind of on the manufacturer side, but don't worry, they were checked. We use a manufacturer who is USDA certified and CFIA certified and all of the good stuff. So, but efficacy and safety were two things we had to do on our end. And it's kind of hard to do research on a pathogen in the field. So our challenge model kind of combines the field and the lab, because we need to be able to control this pathogen without infecting a lot of hives. So step one of the challenge models. I'm sorry, someone's not muted. Would you mind muting? Thank you. So first we vaccinate queens, and then we also had placebo queens. So there were some queens who did not get vaccinated. And then we introduced those queens to hives, and let them start laying eggs. And once they had been in there for a few weeks, we collected frames with first instar larvae, so 24 hours old. And then we grafted those larvae and we placed them on petri dishes with contaminated food. And then we looked at their survival after infection. So we had 30 to 50% more resistant to infection in each case. So we had these, this is how many died. So our vaccinated larvae, we had a 30% less die than our control groups. And in this group, we had 50%. So these numbers might seem a little odd, but the way these studies are done, you want your control group to survive at about 50%, so that you know how to gauge your results of your treatment groups. And these larvae were exposed to 200 times the amount of P larvae that they would actually need to be exposed to make them sick. So in the field, it's more like somewhere between 5 and 200 spores to infect a larva and cause a clinical case, depending on the strain. And these larvae were exposed to 2,000 spores. So the translation of this efficacy into the field, we can sort of hypothesize might be a little bit more effective in the field when they're not being bombarded by a kind of a really heavy dose of P larvae. And then for safety, we looked at the safety of the queens and then also the safety for humans. So looking at honey and So we vaccinated queens again. We placed them in hives, and then we evaluated their survival after they were caged with workers for 8 days in the lab during the vaccination process, and then also in the field, and monitored their survival for several months, and we saw no difference in their survival at that point. And then we also looked at the honey quality and the properties of honey while they had vaccinated queens in place. And you can see we had no difference in queen survival, and then no change in honey over either case. So in the US, so far, we have shipped 7,000 doses into 14 different states. We've had 0 cases of AFB reported. We've had also no negative signs resulted, negative effects, from these hives. So we're not seeing a lot of queen death. We're not seeing rejection of queens. You know, a lot of treatments end up having some kind of kickback result. They help with one thing but hurt something else. And we haven't heard that from any of our beekeepers. We worked with some commercial operations over the last few years, putting in hundreds to 1,000 queens in their operation and monitoring those hives, and everything looks good so far. We've gotten good feedback from the beekeepers. And again, no cases of AFB reported. And we're keeping an eye on some interesting things we've seen that would be some other really positive, helpful things, some positive side effects of the vaccine that we're going to continue to look into this year. So far, so good. Now I'll hand it back over to Everett to talk about how you can access the vaccine.
Thank you, Amy. And again, thanks for that presentation. You may have kind of heard Amy clearing her throat a lot. She's been getting over a 3-week cold. And so the healthiest she's sounded in quite a long time was today. And we were thankful for that. We appreciate you doing that for us, Amy. Always an honor to hear from you. That's about, and as we said, protecting our investment from AFB. We have a lot of invested in our hives, and not just monetarily, right? A lot of time, a lot of passion, and a lot of energy goes into creating what we are proud of in our apiary. And so that's not lost on us. How do we get vaccinated queens into our apiary? And that's why we're here tonight, right? Our partnership with Dancing Bee is one of a kind. And as we've talked to different dealers like Dancing Bee throughout North America, I can tell you personally, I haven't talked to an organization as focused on customer service as Dancing Bee. They are top shelf when it comes to servicing the client, and at least their intention to make sure that everything that the beekeeper needs, questions answered, workshops taken care of, white glove treatment for certain clients. It is amazing the energy they pour into their business, and that passion feeds us as well. So we're so proud to be with them and offering this to the market. They will be carrying vaccinated queens from a certified producer outside of the US that imports into Canada. We have Hawaiian producers that have come on board, and they will be sending queens up. And these are top-notch producers. We looked for some of the best producers that we could find, from genetics to consistency and quality. And we asked them, can we make this work for you with vaccination and getting this to the market for hobbyists and commercials and others? And we have a handful that are certified producers. They've agreed to provide Dancing Bee with the queens that they need for the market and for the clientele that they have. So if you're interested, if you want more information, if you need to purchase, please see Dancing Bee's website. We have a link here that talks about where you can find more information. Shortly, in the next coming days, you'll see a button where you can purchase a queen with a clear price. We are still hammering out the pricing, trying to get it as low as we can, so that the market can see it for what it is. And so in that process, just please stay tuned. There's also an opportunity to take reservations. Dancing Bee, I know, has already quite a few of these queens spoken for. So please reach out to your customer service rep, your sales agent, or through the website, chat them up, email them, and see if you can get on that list. And then once they have that price, they'll shoot that right out to everybody so that you know what it's going to be. As far as if you're a producer, if you're a honey producer, let's say, and you have thousands of hives and you breed your own queens and you want to vaccinate yourself, give me a call. My phone number is posted here. Dancing Bee has it. Reach out to them, have a conversation. If it's more than a couple hundred, it's worth a conversation if you so wish. So that's what you can do if you want to vaccinate yourself. Reach out to me, reach out to Dancing Bee, and we'll have a conversation about it.